In the interactive application of VR and AR, with the help of reverse dynamics, to help determine character movements. This lesson, let's learn the principles and applications of AK together. First of all, we need to know what IK and FK are. Then, we need to understand the implementation principle of IK. And finally, just know where it is used. IK stands for inverse kinematics. What do you mean by reverse dynamics? Relative to reverse dynamics, FK forward dynamics. It's basically a skeletal animation that we use. Animators combine the components of a character, planning through hierarchical nodes. It's like a skeleton. By the correlation coefficient between the joint point and the skin surface. Animators can change the position of skeletal nodes. Rotation angle. Drive the skin to form animation. An animation production method. In an FK system, the general rule is a parent node in the hierarchy. Drive arbitrary sub-node motion. For example, if you move your forearm, that's the parent. Wrist. That is, the sub-node will move with it. But if you move the wrist node, the forearm will remain in place. That is, the movement of the parent node can drive the sub-node. The sub-node movement does not change the principle of the parent node. According to the above principles, reverse dynamics is easy to understand. Reverse dynamics. It is a method by first determining the location of the subskeleton. Then the reverse is deduced. The position of the in-level parent bone in the skeletal chain. To determine the entire skeletal chain. The principle of reverse dynamics is rotation angle by changing the position of the sub-node. Drive the parent node to move and rotate. So here's a real-life animation. You can use it to understand what FK is. Forward dynamics is driving the leaf node through the root node. Through this animation, everyone can understand what it is. Reverse dynamics is leaf node driving root node. In this animation, the palm is pulled back by the force of the basketball. Drive elbow and shoulder joint movements. Got it, IK and FK. What are we going to do in the program? Next, let's understand the principle of IK. Inverse kinematics IK is a way to set animations. It flips the direction of the chain manipulation. It starts with the leaves, not the roots. Here's an example of an arm. To set the animation of the arm using forward kinematics, you can rotate the arm. Move him off the shoulder. Then rotate the forearm, hands, etc. Add a rotation keypoint for each child object. To set the animation of the arm using inverse kinematics, it can move the target used to locate the wrist. The upper and lower parts of the arm, rotated by IK solutions. Point the wrist axis called the end effector. Move towards the target. Some students must have started to think how to implement IK with algorithms. Let's look at strategic thinking. First step. Start with the smallest daughter skeleton. Traverse and approach the goal. Second step. Every bone. Both use the axis points of their daughter skeletons as follow points. Smallest skeleton without subnode. You need to follow the target point directly. Start to approach. The third step. Skeleton follows. The method is: take the direction of its own axis point and the target point as the bone. Change direction. And align the midpoint of the bone with the target point. For example, look at this diagram. PEPRP builds a chain structure. Its length is the first, second, and third respectively. Figure A. Start at the end. Approaching point X starting with P4, P3. Figure B. Third approach. Connect P3X move P4 P3 to P4 P3. Figure C. Second approach. Connect P2 P3. Move P3 P2 to P3 P2. Figure D approach. Connect P1 P2. Move P2 P1 to P2 P1. A classmate asked. If the position of point P1 is fixed, then start at P1. Repeat the above steps again. Back and forth. Start with points P1 and P4. Repeat the above steps. Finally, the middle to joint points can be determined. P to P3 position. Certainly. So you know about these algorithms. The process is not difficult. In the actual game development process, these have been packaged into the game engine. We know where reverse dynamics are used. That's it. Forward dynamics. We need to move by roll. Adjust the order. Adjust the position and rotation angle of each node. By means of motion compensation. Usually used to make fixed sequence frame animations. The advantage of forward dynamics is that simple calculation. Fast operation speed. The disadvantage is the angle and position of each joint need to be specified. And because of the various nodes of the skeleton, it's intrinsically connected. Directly specify the value of each joint. It is easy to produce unnatural and uncoordinated movements. Think about that. Let the character walk on the uneven road. Or you need to make the character hold the stair railing to move forward. Or drive the character to fetch an item and other scene requirements. A preset animation made with forward dynamics. Penetration is likely to occur. Awkward problems like stiffness. And in our VR and AR interactive applications, there are just so many scenes. Is the application of this non-fixed animation So you need to use reverse dynamics to help the role perform properly. Action IC animation can be done by placing end effectors. Reverse adjust the system posture of the entire skeleton. For example, let the character walk on the uneven road. You can determine the roll by the contact position of the foot with the ground. Spin. Automatically calculate the posture of the rest of the body by varying the stride length of each step. Contact with the ground. You can animate the character walking on the uneven road. For example, in VR, to drive the character to pick up items, you can use the VR handle of the character's rest position. Reverse calculation of the character's arm and body postures. Let the character pick up items naturally. And finally, let's briefly summarize the main content of our lesson. First of all, we understand what IC and FK are. I understand the principle of IC's algorithm. Also know the usage scenarios of IC. We will use it in subsequent games.